In this video, I'm going to show you how a general multiplication rule can help you to find the probability of multiple events happening in a row. In this example, you are choosing marbles from a bag with 3 green marbles, 2 red marbles, 1 blue marble, and 4 yellow marbles. Every time you take a marble out of the bag, you put it back before choosing another marble. What is the probability of choosing a green marble? And we're going to use the letter G to represent choosing a green marble. I can write this with my probability notation as P parentheses G, the probability of choosing a green. And this is review from our basics of probability. We need to know the total number of objects in our sample space, and then we need to know the total number of ways we can pick a green marble. Since there are 3 plus 2 plus 1 plus 4 marbles, there are 10 total marbles, so we put a 10 in our denominator, and there are 3 green marbles that we can choose, so the 3 goes in our numerator. The probability of choosing a green marble is 3 out of 10. What is the probability of choosing a green marble on your second pick given you chose a green marble on your first pick? Let's start by writing this using probability notation as well. I'm going to write P parentheses G, and I'm going to use the subscript 2 to represent picking a green on the second pick. Given we pick a green on the first pick, which I'm going to use a subscript of 1 on that G to represent picking a green on the first pick. Now, this is where we have to consider the important piece of information in the problem, which is that every time we take a marble out of the bag, we put it back before choosing another marble. So just visualize with my picture for a minute what it would be like if we picked a green marble out and then put it back and then picked another marble. So if I pick a green marble out of the bag, my example is telling me that before I go to pick a second marble, I'm going to have to put this marble back in the bag, and then I'm going to pick another marble. So as you can see, when I put that green marble back, it brings us back to our original sample space and our original amount of green marbles. So on my second pick, the total number of marbles I'm picking from is still 10, and the total number of green marbles I can choose is still 3. So my probability ends up staying the same. This is due to the fact that we're replacing the marbles. The fact that we replace the marble each time causes the events to be independent, because what we pick the first time doesn't impact what we pick the second time. So as we know, our independence formula tells us that the probability of a conditional statement is the same as the probability of that event without the condition. So for this reason, the probability of choosing a green the second time, given we chose a green the first time, is really just the same as picking a green the second time by itself, which it's the same exact probability we already found, because every time we pick a marble, we have the same sample space and the same number of green marbles. Now we want to know the probability of choosing a green marble twice in a row. So that's the probability of picking a green the first time and picking a green the second time. And as we know, since these events are independent, we can just multiply the probability of picking a green the first time, which is 3 out of 10 on the first attempt, times the probability of picking a green the second time, which is still 3 out of 10 on the second attempt. And when I multiply these, I get 9 out of 100 as the probability of choosing a green marble twice in a row. Now let's do another example. This example might look exactly the same at first, but there is one small difference. We do have the same bag of marbles, so we have the same amount of marbles to pick from, and we have the same amount of each color. The difference is in the example, it says that every time we take a marble out of the bag, we do not put it back in the bag. So this is going to be a little different from the last one. First, we need to find the probability of choosing a green marble, and we will still use G to represent choosing a green marble. So P parentheses G equals the total number of marbles in our sample space is still 10, and the total number of green marbles we can pick is still 3. So the probability of choosing a green stays the same as 3 out of 10. Now, what is the probability of choosing a green marble on our second pick given we chose a green marble on the first pick? So P parentheses G2 given G1, just like before. Now, since we have this different situation where we are not putting marbles back in the bag, let's take a second to visualize it. Let's say I pick a green out of the bag on my first pick, which we know there's a 3 out of 10 probability of picking a green on the first pick. Once I have that green out of the bag, I am not going to replace it for my second pick. So this new bag shows my new sample space for picking a green on the second pick. So in this situation, there's actually 9 marbles to choose from. So my denominator is 9, and there's only 2 green marbles I can pick. So my numerator is now 2. So in this case, our conditional probability is not equal to the probability of choosing a green by itself. And that's because the fact that we are not replacing the marbles, our events are actually dependent. What we pick on the first pick is going to impact what we pick the second time. Okay, so in this case, our events are actually depending on one another. If I pick a green the first time, it changes the number of greens I can choose from on the second time, and it changes the total sample space I'm picking from. So now we need to find the probability of choosing a green marble twice in a row. So once again, the probability of choosing a green the first time is G1 and G2. To find this, we're actually still going to multiply the 2 probabilities we already found. We found that there's a 3 out of 10 chance of picking a green on the first try times a 2 out of 9 chance of picking a green on the second try. And if we multiply these, we get 6 out of 90, which simplifies to 1 out of 15. So I'm going to explain part of why we multiplied these 2 probabilities. So obviously our events are not independent, so it's not that we were using the independence formula. What we did was we took the probability of picking a green the first time and multiplied it by the probability of picking a green the second time, given we picked a green the first time. That's what we did here. And actually, that's exactly what we did before. We picked a green, the probability of picking a green the first time was 3 out of 10, and it just happened that because these events were independent, the probability of picking a green the second time, given we picked a green the first time, was still 3 out of 10, right? Because we know when events are independent, these probabilities are equal. So because we kind of used this same process on both events, we can generalize this into a rule called the general multiplication rule. And that rule says that the probability of 2 events, A and B, occurring is equal to the probability of A times the probability of B given A already occurred. I can also show you how you can get this rule from our conditional formula. If you look at our conditional formula, it says the probability of A given B equals the probability of A and B divided by the probability of B. I can just move some things around in this formula to get it to look just like this rule I just showed you. So I can multiply both sides by the probability of B, and that cancels out the denominator on the right side, and it gives me the probability of B times the probability of A given B equals the probability of A and B. And as you can see, this is actually exactly the same as the general multiplication rule I just wrote down, except the A and B are switched. So now you know that whenever you're trying to find a probability like this of 2 things happening in a row, you multiply